Hi everybody, it's time to hit this final topic of this week, week number 2 online, and that is the eye. Today's lecture comes from section 25.2, and we'll have 2 or 3 of these about the eye today. So let's get with it. We all have 2 eyes, not everybody, but most people have 2 eyes. If we could look at it from the side, it might look something like this. And we have the cornea, the lens, etc., the front of the eye basically right here. We have the back of the eye back here, what's it called, the vitreous humor, the glop, that's inside the eye. Cornea lens over here. Light enters this direction. And then here's the retina in the back with the rods and the cones and so forth, and the light basically enters the eye this way along. This is sort of our principal axis here, and ideally it gets focused right back here on the retina. So your little image, say we're looking at a bug, you have the actual object, the bug, out here in the world in front of you, and what you want is for there to be a nice, crisp, focused image of the bug back here on your retina. So basically the diameter of your eye is the image distance. Okay, it's a real image. Your eye couldn't deal with a virtual image inside of it. The final image here on the back of the eye cannot be virtual. We can see a virtual image, but the image in the back of the eye has always got to be real. So this is our image distance. And for the normal adult human eye, that's about 2.2 centimeters. So here's the lens, and the lens can change shape. Unlike the lenses that I had in here earlier for my demonstrations, unlike the lenses that we have in the lab, our lenses of our eye can change shape a little bit, change the focal length a little bit, in a process known as accommodation. And I will see if I can spell this word correctly. I think there's actually 2 M's. I don't know. You tell me. I think there's 2 M's. And I'm a professor, so I feel like I really can't move forward until accommodation. And that is the process by which the muscles around your lens, around your eye, can actually change the shape of your lens, and that helps you focus on objects which are either far away or close up. Okay, that's the process of accommodation. Now the eye, I'm drawing a picture of this over here. So this is a normal human eye right there. And let's just sort of put an axis out here in front of it like this. Okay. There are 2 points, okay, that are important to us, and we talk about the eye. And this line's going to make me slightly bonkers being right in front of my face here in the middle. There is a point called the near point. Okay, and that is, let me get the wording right here, that is the closest distance for which the eye can accommodate. The eye, the eye. Two M's. Okay, and you can all experience this yourself. Get a piece of paper with some writing on it. get a pen with some writing on it and bring it close to your eye, and there's a certain distance within which, no matter how hard you strain, you cannot get a clear image of this. It always looks fuzzy. And that distance is your near point. If you're closer than the near point, then you can't get a good focus on it. If it's further than the near point, then you can. So that's the near point. Okay. And there's another point, believe it or not, called the far point. All right, far relative to the near one. And that is the furthest. And then all the rest of the words are the same, dot, dot, dot. Let me just do it this way. Furthest distance for which the eye can accommodate. The furthest distance for which the eye can accommodate. That is the far point. Okay. Now, for a normal human eye, the near point value tends to be something along the lines of 25 centimeters. Okay, now this distance for the near point, that's typical near point value, 25 centimeters away. Now, I've got an 11-year-old at home, and her near point is closer. It's maybe about 10 centimeters. For you, you know, a college student, young adult, probably more like 25. For me, it's further. And the older you get, the further it gets. In general, for the typical human, as you get older, the near point gets further and further away. And that's why, you know, my dad used to say things like, he'd be reading a book like this, and he'd say, you know, my arms are getting shorter, or something like that. You know, dumb joke like that. So it gets, as my dad got older, his near point got further away, so he had to hold things further and further back in order to read them. Therefore, the joke about the arms. For a far point, for a healthy eye, okay, healthy eye, the far point is actually infinite, right? A healthy eye can focus on the moon. It doesn't matter how far away the object is. A healthy eye has a far point of infinity. Okay. But as we'll see in a minute, it can be less. It can be less than this, but less than this if the eye is unhealthy. My words are not coming today. My writing is, I'm not sure what's happening here with all this, but it's giving me a hard time. Unhealthy. Okay. So typically the near point is always, you know, fairly close in, you know, centimeters, meters, whatever, but the far point can be infinitely far away or closer for an unhealthy eye. Okay, so that's it for our first lecture here. I think that's it. Next lecture we're going to talk about nearsightedness and farsightedness, and then after that we're going to do an example. Okay. Button is not working.